Hello. In the last video, we derived the formula for curvature in terms of velocity and acceleration. And that's going to be your working formula. Somebody gives you a function, a vector function in terms of t, you can calculate its curvature rather quickly. Now let's look at this calculation for the standard helix that we did the other ways and got the same value. But let's do it for the one also that we couldn't do the other ways. And so we have the helix with 3 sine t and 4t and 3 cosine t. We already know the answer is 3 over 25. But let's use this velocity acceleration formula. So derivative is velocity. So 3 cosine t and 4 and negative 3 sine t. We found out that its magnitude was 5, constant. The second derivative is acceleration. So negative 3 sine t, 0, and negative 3 cosine t. And I think I leave them as r prime and r double prime. But yeah, velocity cross acceleration is what we need to look at next. All right, cross out i's column and row, and you get negative 12 cosine t. Cross out j's column and row, you get negative 9 cosine squared minus 9 sine squared. And forget though, the second term there gets a negative on it already. And then when you cross out j's column and row, you end up with a 12 sine t. So your cosine squared plus sine squared shows up. That's a 1. The double negative makes it a 9. We have our cross product. What are we going to do with that? The formula for curvature has us taking the magnitude of this cross product. Square each component. You got your first term, which gives you 144 cosine squared. Your last term gives you 144 sine squared. Let's write them next to each other. Don't forget to square that middle guy, though. Also, we have 81. Cosine squared plus sine squared is 1. 144 and 81 happen to add up to a perfect square. 225 is a perfect square. It is 15 squared. So the numerator of the curvature is 15. Denominator of the curvature is speed cubed. Speed is 5, so 5 cubed, 125. And then you just divide out by 5 and you have the original 3 over 25. So nice and easy for the helix with a constant curvature. But don't think curvature will always be constant. Curvature in general is going to be a function of time. Where you're at on how much time has passed, where you're at on the curve based on how much time has passed, you'll get a different amount of bend. Remember, curvature, we're measuring the degree of bend. Okay, so let's go back to the one that we couldn't do any other kind of way. We tried it with the definition. We tried it with the first formula on t. It just didn't work out. Now let's try it using our velocity cross acceleration formula. Derivative would be 2 and 2 root 3t and 3t squared. We found out that magnitude was 3t squared plus 2 when we were doing arc length a few videos back. That's the speed. Second derivative would be 0 and then 2 root 3 and then 6t. All right. Velocity cross acceleration. So we have the derivative on line 2 and the acceleration on line 3. ijk on line 1. Or row 1, row 2, and row 3. And we got to do this cross product now. What we get is negative, we get 12 root 3 t squared minus 6 root 3 t squared for the I component. For the j component, we just get 12t but with a negative on it. And for the k component, what we get is 4 root 3. Putting the two parts together from the first term, that combines nicely to be 6 root 3 t squared. But we don't want this vector. What we want with this vector is the magnitude of it. The numerator is the magnitude of it. So square, 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 add them all up. 6 root 3 squared is 108. 12 squared is 144. 4 root 3 squared is 16 times 3, 48. So there's a t to the fourth. There's a t squared. It looks like a quadratic. The numbers are kind of large. Let's factor out. They have in common a 12. 12 goes in all these guys. 108, it goes in 9 times. 144 goes in 12 times. 48, it goes in 4 times. and you're on your way to seeing what's happening there, you're going to then take what's in the parentheses, the factor that's left over, and recognize it as a perfect square. It's the same, 3t squared plus 2, quantity squared. And so we end up with the root of 12 and then the root of this perfect square. So the root of 12 is 2 root 3. And then we have that perfect square there, the thing that was a perfect square underneath the radical. That's the numerator to curvature. What's the denominator? It's speed cubed, but look at the speed. The speed is the same factor here, 3t squared plus 2. So in canceling, you'll have the curvature 2 root 3 over 3t squared plus 2. All right, let's look at one more example here. Calculating curvature. This function is a little more complicated. It has these two terms in the I component, similar two terms in the J component, K component, just the 3. Remember the formula for curvature? Velocity cross acceleration's magnitude divided by speed cubed. So velocity would be the derivative of this guy. I've color-coded it here, the product rule that comes in from taking the derivative of the second term from each of those I and J components. Cosine t's derivative is negative sine t. Then we have a product rule on t sine t. T's derivative is 1, leave sine t alone, put a plus sign, leave t alone, and take sine t's derivative, who's cosine t. That's the fuchsia part is where I'm taking the derivative using the product rule. Then we move to the second term. Sine t's derivative is cosine t. And then we have negative t cosine t's derivative. Negative t's derivative minus 1, leave cosine t alone, leave negative t alone, and cosine t's derivative is negative sine t. So what's in lime or highlighter green there is the product rule, each individual derivative parts. And the constant term in K has a 0 as its derivative. Can you see what's happening in the I component? Look at the first part. We have negative sine t and plus sine t. In the J component, cosine t and then minus cosine t. So it works out nice. Simplifies to be t cosine t for the I component, positive t sine t for the J component, and a 0. All right, that's the velocity vector. What is its magnitude? Square, 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 and add. But, you know, cosine squared plus sine squared there, so that's a 1. So now technically the square root of t squared is not just the t, unfortunately, it's the absolute value of t. T can be negative in there, I guess. All right, so we have our denominator, or part of our denominator. We have the speed. We have part of our numerator. Not really, we just have the velocity. Let's go get the acceleration. So speed is absolute value of t. Now let's get acceleration by taking velocity's derivative, product rule, derivative first times the second plus the first times the derivative of the second, and then do it again, derivative first times the second plus the first times the derivative of the second there. We have velocity's derivative, who is acceleration. No cancellation though, unfortunately. So the acceleration vector will look a lot like the original position vector. And we are ready to cross these two guys. Whenever you have a 0 in the same component and you're doing the cross product, it tremendously simplifies your work. Your answer is only going to have the one dimension. You're going to have 0 for the other two dimensions. You're going to have, for the I component, cross out I's column and row and you'll have 0. For the J component, cross out J's column and row and you'll have 0. When you cross out K's column and row, that's when you get something. It's t cosine t sine t, t squared cosine squared, minus t cosine t sine t, minus t squared sine squared, with the double minus there. Just be careful. So the t cosine t sine t and the minus t cosine t sine t cancel each other out, leaving you with t squared cosine squared plus t squared sine squared. That's familiar. That's just t squared. But we want its magnitude. It's just t squared. So the numerator to curvature is t squared. Denominator curvature is absolute value of t quantity cubed. And you can actually cancel the absolute value of t and the absolute value of t. Two of those guys can cancel with the t squared from above. And the answer is 1 over the absolute value of t. That's what curvature is. You can't have a negative curvature. That's why we have to really be careful with the t there in the absolute value bars. That was a tough one, but we did it with this nice formula. With those other formulas, forget about it. All right. Thank you for watching. My name is Nakia. Remember, here to help you through this journey of multivariable calculus. We're making our way through curvature. We've done a bunch of examples, and we're headed on our way to actually looking at cutting off this vector function, intro to vectors unit, and jumping into actual multivariable calculus. Please like and subscribe, comment down below. If you have any questions, reach out to me. And yeah, I'll see you in the next video. Thanks for watching.